In this lesson, we'll focus on writing linear equations from a table. So I've got a lot of tips for you in there in your packet, so I'll want you to read them, but what I'm going to do is just go ahead and talk you through how to do this first example using these steps. So you're going to notice that, first of all, you're checking to make sure that the table has a constant rate. Okay, so you want to look between the variables. So you're going to look from 8 to 14, it's increasing by 6. From 14 to 20, it's increasing by 6. From 20 to 26, it's increasing by 6. And all of these are happening while x is increasing by 1. Notice the step says that the value that y continues to change at when x changes by 1 is your rate of change. That becomes the multiplier in your equation. We're going to use y equals y equals mx plus b. So in our equation for this particular example, we're going to start out with y equals 6x plus or minus something. So then what you're going to do is take any random x value that you see on your table. So for instance, I might say, well, I see this 3, okay? And I'm going to put it into my equation. So y equals 6 times 3. And I typically do this mentally, but I'm going to write it out just for you right now. So y equals 6 times 3, that's 18. But notice what you want to do is you're looking for an answer of 20. So I ask myself, what do I have to do to 18 to get 20? Well, I have to add 2. So I'm going to add 2 onto my equation. So I believe my equation is y equals 6x plus 2. To check that I'm right, I like to just look at any other pair. So like here, 6 times 4 is 24. If I add 2, I get 26. If I did this first one, 6 times 1 is 6. If I add 2, I get 8. And the last one, 6 times 2 is 12. If I add 2, I get 14. That equation seems to work every time because what I have to do from x to get y is multiply it by 6 and add 2. So I get the equation y equals 6x plus 2. All right, let's try a few more. I'll do another example for you. So here, our first step is always check out if it's a constant rate, and if so, figure out what that rate is. So from negative 10 to negative 15, it's going down 5. It goes down 5 again, and it goes down 5 again. And since x keeps changing by 1, this is good. That means my constant rate is negative 5. So I'll start my equation by y equals negative 5x. And if I check it, like say I use this ordered pair 2, well, negative 5 times 2 is negative 10 already, so I don't have to add or subtract anything. In fact, if I try that for each time, negative 5 times 3 is negative 15, negative 5 times 4 is negative 20. It works every time. So y equals negative 5x, that's my final equation. I don't have to add or subtract anything. All right, why don't you try this number 3 on your own and then come back and see how you did. So I hope that you started this by noticing from negative 3 to negative 1, it goes up 2. From negative 1 to 1, it also goes up 2. And from 1 to 3, up 2. Every time x is counting by 1. So your multiplier should be y equals 2x. The multiplier is just the 2. And if you plug in a point, so say I pick 3. 2 times 3 is 6. To get to this answer of 3, I have to take away 3. So I think my answer is y equals 2x minus 3. And you should double check that by other points. So like, for instance, 2 times 0 is 0. 0 minus 3 is negative 3. It seems to work. 2 times 2 is 4. Minus 3 is 1. Keeps working. It actually works for all the points. All right, final example. Try to see what makes this one trickier, why you think I might have saved it for last. I hope you can notice here that x is not counting by 1s. So like here, y is changing by 6, but x is changing by 2. Y is changing by 9, but x is changing by 3. Y is changing by 6, but x is changing by 2. So if you're going to figure out what the rate is, you have to figure out how much y goes up by when x goes up by 1. So you have some different options here. You can, I usually just like to do this method of dividing. 6 divided by 2 equals 3. 9 divided by 3 equals 3. You can also try filling in the gaps, like what if I put a 4 there to make it count by 1? Well, this went up 6, so each time it goes up 3. So it would go 5, 8, 11. But whatever, you're going to figure out that your multiplier is 3. So your equation is going to start out with y equals 3x. And then again, I'm going to look at what I need to add or subtract to get to that final answer. So if I do like 3 times 3, I get 9. It looks like I have to take away 4 to get to 5. If I had tried like 10, 3 times 10 is 30. Take away 4 to get to 26. Make sure it matches every time. And this equation is y equals 3x minus 4.